Hello everyone, in this video I'm going to discuss the example for function and graph and also the limit and continuity. Sketch the graph for the function fx where we have fx which is equals to the square root of, so we have 3x minus the 1, 3x plus with the 1. Then state the interval where the f is continuous. So kindly refers to the situation. First we are going to find the domain. So based on the situation where we have 3x minus the 1, 3x plus with the 1 greater and equals to 0 because of the square root. Next, here we have the simplest form. So kindly determine the sign. We have the positive. Continue. We have x greater equals to 1 over 3. X greater equals to negative 1 over 3. Kindly illustrate the situation in a real number line. So where we have negative 1 over 3 and 1 over 3. Then circle towards the right, then circle towards the right. So here we have the negative, negative and negative. So positive, negative and positive. So select the sign, we have the positive. So here will be the domain. So the domain for the f would be negative infinity until negative 1 over 3. Union, start from 1 over 3 until infinity. So that is the domain for the situation. Next, find the xy intercept. So for the x-intercept when y is equals to 0. So kindly substitute the situation where we have 0 equals to square root. We have 3x minus 1, 3x plus with the 1. So we square both sides. Then we will have 3x minus 1, 3x plus with the 1. So x is equals to 1 over 3, x is equals to negative 1 over 3. So that is the xy intercept where we have 1 over 3, 0. Negative 1 over 3, 0. Continue. We have the y-intercept when x is equals to 0. So kindly substitute. So we have y is equals to square root 9 multiplied with the 0 minus the 1. So y is equals to square root of negative 1. So does not exist. So there is no y-intercept. Continue. Next is to find the vertical asymptote. So limit when x approaching where we have the situation negative 1 over 3 from the left. Limit when x approaching negative 1 over 3 from the right. Continue. Limit when x approaching 1 over 3 from the left. Limit when x approaching 1 over 3 from the right. So kindly substitute the situation where we have the square root bracket 3x minus 1, 3x plus with the 1. Square root, we have 3x plus with the 1, 3x minus the 1. So by referring to the real number line, where we have negative 1 over 3 and 1 over 3. So negative 1 over 3 where we have negative 0.3 with the repetition 3. So from here we have negative 0.3334. As for the right, we can see that based on the domain does not exist. Next, we have 1 over 3. As for the left, does not exist. Then we have 0.3334. So kindly substitute the situation. So for this case, if we substitute the value negative 0.3334 into this part, then we will have the value approaching to 0. So same goes to this part. So we will have 0. So as x approaching negative 1 over 3 from the left for the function fx, the value of y will be approaching 0. As for the right hand side, we have does not exist. So you may refer to the number line. Continue. If we substitute in this part, for sure we will have does not exist. Again, for this part, if we substitute, we will have the value approaching 0. Same goes to this part. So the value of x. So the limit when x approaching 1 over 3 from the right, we will have the value of y approaching 0. Continue. We have the horizontal asymptote. Limit when x approaching negative infinity. Square root, we have 9x squared minus the 1. If we substitute the negative infinity, and we will have the positive infinity. Limit when x approaching positive infinity for the function 9x squared minus the 1. And the value of y will be approaching positive infinity. So kindly refers to the graph. So we have the y-axis and the x-axis. So first refers to the domain. We have negative 1 over 3. Then here we have 1 over 3. Then based on the x-intercept, we have 1 over 3, 0, negative 1 over 3, 0. So here will be the location. Negative 1 over 3, 0. Then here we have 1 over 3, 0. Next, we have the y-intercept does not exist. Vertical asymptote as x approaching negative 1 over 3 from the left. We have the value approaching 0. So where we have here. Continue, does not exist, then does not exist, then limit when x approaching 1 over 3 from the right, approaching 0. Limit when x approaching negative infinity, we have the positive infinity. So meaning that the graph will be something like this. Same goes to the right hand side, we'll have the graph something like this. So where we have the fx, which is equals to square root of 9x squared minus the 1. So state the interval where the f is continuous. So based on the domain, so the interval would be negative infinity until negative 1 over 3, union from the 1 over 3 until infinity. So continuous for the fx. Next, function g is defined as the follow situation. So given that g is continuous for all the value of x, find the value of the constant m. So based on the situation here, they mention continuous, so meaning that limit exists. So limit when x approaching 1 over 3 from the left for the function gx is the same for the limit when x approaching 1 over 3 from the right for the function gx. So let's focus on the situation. Limit when x approaching 1 over 3 from the left. So refers to the situation here, we have the number line. So they mention 1 over 3 until 1 over 3. So x is a subset in negative 1 over 3 until 1 over 3. So meaning that here we have m squared plus with the 3. Then not included means that we have the square root 9x squared minus the 1, square root 9x squared minus the 1. So kindly refers to this part, 1 over 3 from the left. So we will have mx squared plus with the 3 equals to limit when x approaching 1 over 3 from the right for the function square root 9x squared minus the 1. Kindly substitute the situation. So here we'll have m over the 9 plus with the 3 equals to, kindly substitute 1 over 3, so we will have the square root 9 bracket, we have 1 over 9 minus the 1. So we will have 0 on the right hand side. So kindly continue. So m over 9 plus with the 3. So m over 9, which is equals to negative 3. So m is equals to negative 27. So here we have the function h is defined as the situation where we have the hx, which is equals to 3x minus the 1 over, we have the square root. So if we factor the situation, 3x minus the 1, 3x plus with the 1. Or you may rewrite the situation, 3x minus the 1 over the square root of 9x squared minus the 1. So state the interval of continuity of h. Find all the asymptote of h, hence sketch the graph. So number 1 would be find the domain. So as we all know, in here, we have all real number. Next, focus on the denominator. We have 3x minus the 1, 3x plus with the 1 greater equals to 0 because of the square root. But for this case, we have the square root is at the bottom, which is the denominator, so it cannot be equals to 0. So rewrite the situation. So we have greater than 0. Then we have the simplest form. So determine the sign where we have greater than 0, which is the positive. So x greater than 1 over 3. X greater than negative 1 over 3. Illustrate the situation in a real number line. So empty circle, empty circle. Then we have the negative, negative, negative. So it becomes positive, negative, and positive. So here is our selection based on the sign in here. So the domain for the h will be negative infinity until negative 1 over 3. Where the negative 1 over 3 is not included, union we have 1 over 3 until infinity, where the 1 over 3 is not included. So that is the domain. Or we can say the interval of the continuity of H. Second step is to find the xy intercept. So x-intercept when y is equals to 0. So y-intercept when x is equals to 0. So based on the domain, when x is equals to 0, y, no solution. So meaning that y-intercept does not exist. As for the x-intercept, when y is equals to 0. So if we substitute, then we will have the situation 3x minus 1 equals to 0. So x is equals to 1 over 3. So based on the situation where we have to refer to the domain, actually this one does not exist because the domain is not allowed when x is equals to 1 over 3. So meaning that the x-intercept also does not exist. Next, continue. Find the vertical asymptote. So limit when x approaching negative 1 over 3 from the left. Limit when x approaching negative 1 over 3 from the right. Limit when x approaching 1 over 3 from the left. Limit when x approaching 1 over 3 from the right. So kindly substitute the function where we have 3x minus the 1 over, we have the square root 3x minus the 1. 3x plus with the 1. So repeat for the other cases. So based on the situation, kindly refers to the real number line where we have 0.3333 negative. So here we have 0.333 as an approximation. So refers to the left hand side, we have negative 0.3335. This one does not exist. This one does not exist. So here we have 0.3335. So if we substitute the value for this part, then we will have a negative value. So here we will have a negative value. Same goes to this part, we will have negative value. So the value of y will be approaching negative infinity. As x approaching the negative 1 over 3 from the right, based on the domain and also the number line, here we can say it does not exist. Next, refers to the 1 over 3 from the left. So as we all know, based on the number line and also the domain, here we have does not exist. Finally, so as the x approaching 1 over 3 from the right, we have to substitute this value. So if we substitute, then notice that we will have, then from here we can set the vertical asymptote x is equals to negative 1 over 3, x is equals to 1 over 3. So next we are going to find the horizontal asymptote. So limit when x approaching negative infinity. Limit when x approaching positive infinity. So kindly substitute the function. So here we have the 3x minus 1 over, we have the 9x squared minus the 1. So kindly refers to the situation. We have square root of 9x squared. So based on the situation in here, square root of x squared, which is equals to the modulus of x. So based on the definition, we have the positive x and the negative x. For the domain, x greater equals to 0, x less than 0. So meaning that if it's a negative infinity, we will have a negative x. As for the positive infinity, we will have the x. So substitute the situation, limit when x approaching negative infinity, and we will have the IDF where we have infinity over infinity. So what we have to do is to divide the numerator and also the denominator with the highest power of x, refers to the denominator. So as we can see, we have the square root x squared. So meaning that we have to factor out the x. So limit when x approaching negative infinity, factor out the x and we will have 3 minus 1 over the x. Over, we have the square root x squared. Multiply with the square root where we have the 9 minus 1 over x squared. By referring to the situation in here, the square root of x squared, which is equals to the modulus of x, then we have the definition, x approaching negative infinity, so meaning that towards the left, we have to make use of the negative x. So kindly substitute. limit when x approaching negative infinity, we have the x multiplied with 3 minus 1 over x, over, we have the square root of x squared, meaning that we have to substitute negative x, multiply with the square root 9 minus 1 over x squared. So kindly simplify. So limit when x approaching negative infinity. So here we have 3 minus 1 over x over the square root of 9 minus 1 over x squared. So if we substitute the value negative infinity for this part, we will obtain 0. Same goes to this part, we will obtain 0. So as a conclusion, the value of y will be approaching 3 over, we have the square root of 9 where we have the 3 as well. So do remember, here we have the negative. So the value of y will be approaching negative 1. That one is for the left hand side. So limit when x approaching positive infinity, for the situation, we have 3 minus 1 over x, over, we have the square root of x squared, square root of 9 minus 1 over x squared. So for this case, we have the positive infinity, meaning that towards the right. So make use of the x. So limit when x approaching positive infinity. So here we have x bracket 3 minus 1 over x, over, we have the x, multiply with the square root 9 minus 1 over x squared. Limit when x approaching positive infinity. So we have 3 minus 1 over x over the square root of 9 minus 1 over x squared. So finally, the value of y will be approaching 1. So for the horizontal asymptote, we have y is equals to negative 1, y is equals to 1. Next, we are going to sketch the graph. So number 1, we have the domain where we have negative 1 over 3. Then here we have 1 over 3. Second step refers to the intercept. As for the x-intercept, where we have the status does not exist. Same goes to the situation for y-intercept, does not exist. Continue. For the vertical asymptote, here we have the vertical asymptote. So this is what we have. X is equal to negative 1 over 3. X is equals to 1 over 3. Continue for the horizontal asymptote, where we have y is equals to negative 1. Then we have y is equals to 1. So based on the situation, this part, the vertical asymptote, x approaching negative 1 over 3 from the left, the graph will be decreasing. As x approaching 1 over 3 from the right. So next, based on the situation, we have the horizontal asymptote. As x approaching negative infinity, then we will have the situation approaching negative 1. So here will be the situation. Refers to the situation x approaching positive infinity. So the graph will be approaching y equals to 1. So basically the graph will be something like this. So where the 1 over 3, 0 is not included. So that is the graph for hx, 3x minus the 1 over the square root of 9x squared minus the 1. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.